Hi, this is Saurabh from Fangs. Welcome to our demonstration of the automated AI-powered scheduler, a groundbreaking solution designed for optimizing technician scheduling and dispatching. The task of scheduling technicians for various jobs is deceptively complex, far beyond the simple act of matching personnel to tasks. This complexity arises from the multifaceted nature of operational demands and the intricate web of constraints that must be navigated to achieve the optimal scheduling. At the heart of this challenge are several key factors: diverse skill sets, availability and constraints, task hierarchy and dependencies, resource optimization, and dynamic changes. The automated AI-powered scheduler tackles this challenge head-on, utilizing advanced algorithms and machine learning to analyze, predict, and optimize scheduling decisions in real time. The system does not make scheduling more efficient, it transforms it into strategic asset that can significantly enhance operational effectiveness. Building on the foundation of our cutting-edge AI scheduler, we aptly named this solution the OWL service. To enhance user interaction and operational oversight, we developed a suite of sample UX concept designs to seamlessly integrate with the OWL service engine. The user experience designs are more than just interfaces. They are the gateway to setting up and managing scheduling process intuitively. Users can input crucial job details including dependencies, required skill set, estimated completion times directly into the system. The strength of the OWL service lies in its ability to take the detailed input and transform it into coherent optimized schedule, all while providing a bird's eye view of the operational through sophisticated visualization tools. Hi everybody, welcome to our in-depth demonstration of the next generation automated AI-powered technician scheduler, a transformative tool designed to redefine the efficiency and effectiveness of technician scheduling and dispatching in today's dynamic operational landscape. In this demo, we are excited to showcase the core of our system, the advanced AI engine. This isn't just a tool, it's a comprehensive solution crafted to analyze, predict, and optimize the assignment of tasks by navigating through the web of practical constraints with ease. So let's just dig in. The input to the engine are a couple of key data elements like the roster of technicians. These are your people with multitude of skills. They could be sheet metal workers, they could be carpenters, they could be inspectors, whatnot. And a single person can do multiple jobs as well. So the system can recognize that and assign the right people to the right job. And that's one of the key optimization rules that the AI optimizer will follow as well. So that's, the big thing is this roster of technician. And also keep in mind, they could be transient. That means one of the guys may not show up on certain day, or, they are available for half of the day. The scheduler is able to account for all of that as well. The other big element is the job list. So these are your jobs for that given day, the given week, given month, on whatever time horizon you are optimizing against. So these are the jobs, and each of the jobs have a lot of subtasks that you could optimize, put in hierarchy, like a subtask A must be performed before the subtask 2. For example, your tear down must happen before you even put on the new roofing, or the inspection needs to happen after the job has been completed. So it is able to handle those hierarchical subtasks with ease. Within the subtask itself, you are able to assign what kind of skills are needed to perform that task in itself. And I will cover that in a bit, but you are able to have, so that the right peoples are kind of assigned to the right subtask. And you're also able to define how many estimated hours they would be spending on that task and how many people you need. So you can see that the complexity of the optimization starts to ramp up very, very quickly in a practical scenario, right? So the AI engine is able to take all of that and come up with a dispatch schedule or an overall schedule, and you can view it and see it in different ways. But that's the overarching idea behind the AI engine. So to dig in a particular demo example, let's say you have 13 techs, 5 different jobs for a given day, and 5 different tech types, technician types. And we just took a couple of examples. For example, you have sheet metal workers, carpenters, thermal insulator technicians, waterproofing, and roof inspector. And they could be anybody out there, or we can change those on the fly. This all can be customized very easily, right? So what a typical job would look like. For example, we have 5 of these jobs. I have a couple of snapshots on each of the jobs. For example, this one, you need sheet metal worker, you need 2 techs for 3 hours to do that subtask first, and then followed by carpenter. First, we need 1 for a 2-hour period, then we need 3 additional ones for 1-hour period. And these are all arbitrary, but you can see where we are going with this. And then in the end, you need a waterproofing technicians for, 1 technician for 2 hours. So again, we are arbitrarily setting these jobs up, but we are kind of trying to demo you how it would take a lot of these jobs and optimize the schedule for that given day. This is very interesting. The job 2 is open for a shorter period. It opens at 8 a.m. and goes up to 6 p.m. So, and the other jobs are from 8 a.m. to 6 p.m. or any other window you want, but we want to showcase for this particular demo that is able to account for the windows on which the site is available as well, so that the scheduler is able to assign the right person to get to the job on the right time so that it gets done, right? So get a couple of more examples. This is a little bit of a bigger job 5. Again, we can expand this, but we are only dealing with 12 so personal. So once the data is fed into the engine, it starts creating the schedules, right? So for example, for the task is the job number that we see, the job 1, it is able to assign exactly which technician needs to start at what time. The start 0 means it's the 0th hour of the working time. So, and you needed 2 of them, so assign 10 and 12. Starts at 0 hour, and then it goes for 3 hours for that assignment, and it goes on to the subtask 1. It needed a technician 1, and so on and so forth. So you can see that it assigned all of the technician to the subtask, and the subtasks are all hierarchical, that one thing needs to happen before the other. So it is able to do that, and it did that for all the 5 jobs. And there's another view, which is the technician view. So the technician see where do they have to go today and what are they working on. For example, this technician 1 is on task 4, subtask 0. It starts at 0 hour and goes up to 3, and so on and so forth. So it's the same data, but it's for a different person, it's a different view, so they can get what are they doing today, where do they have to go. It's all out there. So this is the schedule, right? So you're assigning resources to right job, at what time, what is the end point, and it's very cognizant about what is the work window for each of the job site. It is also matching the right technician with the right job, and also making sure there's no overlap, there's no double booking or anything like that happening. So that's the scheduling part of it. But it goes beyond that. Like we were saying that, it is not just a tool to schedule, but it also gives you a lot of insight into the distribution of workload, for example. So you can see with just again, these are raw output from the AI engine itself, but this would be all connected to a front end so that it becomes more and more easy to use going forward. And we'll showcase some of the screens later on. But just to view it, so the star represent what they are doing, if they are booked or they're working on something, and the dashes represent that they are open at the time. And you can see that how all the jobs for an 8-hour period, or sorry, this is a 10-hour period, how they are distributed, what are they doing, each of the technicians at different times of the day, right? So the other one is the utilization rate. So you can very quickly see technician 10, you can see it's a sheet metal worker. He has a 30% utilization. this person is a dual skilled carpenter as well as a sheet metal worker. He has an 80% utilization, and so on and so forth, right? So we can apply additional constraints to make sure the work is distributed evenly. But just to give you an idea that this brings a lot of insight that whether you need more carpenters, you need more roof inspectors, or sheet metal workers, or any other type of technician skill, we can aggregate that over a month-long period or 6-month long period and say that, hey, if you have a shortage at a given location for a certain skill type, right? We got to ramp up on that to support more workload, or the jobs wouldn't get completed. That was a quick run through to through an example which I kind of presented in a PowerPoint format. Let's look at the engine directly, which is an API service. We're going to make a couple of calls, change some of the settings, and see how the output looks like from the machine, from the AI engine itself. And keep in mind that this API is very easy to be connected to any front end, right? So that's that. So we're gonna pull up Postman. We have the data already loaded. Just a quick overview. We have the task data. This defines the different jobs. Each of this number represents the subtask within each of the jobs there is, right? So for example, this is the first job. You have 4 different subtasks involved. Each of the number represent what skills you need, how long you need them, and how many people you need to be able to do that job, right? So you can see this is hierarchically set up, 5 different jobs. You have different technicians, 0, 1, 2, 3 represent the technicians and what are the skills they have. So these numbers in the brackets are the skills they process, and the dictionary is set up over here. Sheet metal worker, carpenter, thermal insulator, waterproofing, roofing inspector, so on and so forth. And you can see a couple of them also have multitudes of skill, right? So same person can work as a sheet metal worker, can also do inspection, so on and so forth. But again, you are free to choose. This is an arbitrary example. The other cool aspect of is the job time windows, which is going to be very important for jobs like this. Not all jobs are always available. Some might be open for certain hours of the day, so you can define all of that in this setup as well. So and then, yeah, that's the input. So we'll be setting those in the front end, and a lot of would be static, like the roster, and the jobs. Those are coming in for as they are getting booked. So the system would run automatically, and you hit the make that API call, and the output, you can see that it took less than a second to get a solution, right? And of course it would get more and more complex as you have a lot more people, a lot more jobs. So it's a bigger solution space, but you can see it's fairly quick, or it is really quick to get to a solution. So this is hard to read. I'm going to pull over the raw output from the API, and you can see that this is the output. We made the API call, and then it goes by subtask for each of the elements, and then it finds a solution. Or if it doesn't find a solution due to staffing constraint, we mentioned that. And then for each of the jobs and each of the subtasks, it assigns a technician, assigns a start and the end time as well. And then another view for each technician, they know exactly which job to pick up, which tasks to do, and what time is the starting target and estimated end time as well. And then the distribution of the workload by the 10-hour period on which they are working by each of the technician, and then also the utilization for that given day. Right, so these are some of the output. So let's change certain things over here and see how that fares. So for example, I'm gonna let's say we made a change in the schedule. We are not going to do the inspection today. We probably need 2 of these people, some things like that, right? You hit the button, optimization's done, right? So it found a schedule that matches this setup. Again, let's find. So again, you can see that it now has a new schedule up, and it assigned that with the different technicians. They got moved around, and it found the right people for the right job. So again, this is a very quick demo of the engine itself, but I think it gets the idea across that we have a AI engine which is able to take multitude of constraints and come up with solutions which are optimal. And in case it can't find a solution, it's going to mark that and say that, hey, for this given job, I can't fulfill it. So let's just run that negative case as well. Let's just assign. You only have a handful of people. Let's say we assign like 12 people to that, but you only have a handful of metal worker, right? So when you hit that and take a look at the solution, you would be able to see that it is could not staff because you really don't have that many metal workers, right? So, but it was able to staff all of the other subtasks and other of the other jobs itself, right? So, just to kind of showcase that it is able to still add, even if you give it an impossible optimization problem, it is able to partially solve it and also mark the points where it couldn't get solved, right? So, just a quick note that we showed both the positive cases as well as the negative cases. So.